In this video, we're going to review for your quiz. As I mentioned in class, you are going to be able to use your notes on this quiz. However, you will only have one class period, so it's important that you have all the information succinctly in one place. So it might be a great idea to grab a sheet of paper. Yes, really, go grab a sheet of paper right now and do these problems with me and kind of use them as a guide as you do your quiz. The first topic on this quiz is converting between rational exponents, which is like x to the 3/4, and radical form. So in class, I told you exponent over index, E-I-E-I-O. So this is equivalent to, the index would be the 4th root of, keep the base the same, of x to the 3rd power. If you have more than one number in your base, like 2x raised to the 3/5 power, it's important that when you draw your radical sign that your 2x stays in parentheses. So again, EI, exponent over index, would be 5 and a 3 on the outside. You might see that this is also equivalent to where you distribute this, so 2 to the 3rd would be 8x cubed. Our next topic was then learning to simplify rational exponents. We're going to do the cube root of 80x to the 5th y. So we began by making a factor tree. Your tree might be different than mine, but our factors at the bottom should be identical. So I'm looking for groups of 3 because my index is 3. So I have 1, 2, 3 2's. So that means I'm going to draw my radical sign again, the cube root. 1, 2 will come on the outside, and then I have a 2 and a 5 left over, so 2 times 5 would be 10 on the inside. Now I'm going to go to x to the 5th. Well, exponent over index. This means I'm saying how many times does 3 go into 5? It goes in 1 time, so x to the 1st, and I have 2 left over, so an x squared is still on the inside. And then y is not going to come out because it has an exponent of 1, so this simplifies to this. Let's do one more. This time I have a coefficient out front, so I'm going to begin again by making my factor tree for 162, which would be, let's see, 81 and 2, 9 and 9. Each of these break into 3's. And I'm going to kind of split this up. I've got a -4, which was started on the outside, so that stays on the outside. And I'm looking this time for groups of 4 because my index is 4. So I have a group of 3 4's, so 1 3 comes out, and I got a 2 left over that stays on the inside. Now I'm going to go to my variables. I have an x to the 8th. Well, exponent divided by index, 8 divided by 4 is 2, so that means an x squared comes out. Then I have a y to the 5th. Well, that would be y to the 5/4, and since 4 goes into 5 one time, 1 y comes out. You have 1 left over, so y stays inside. Do one more step of cleaning this up by multiplying it together to get -12 x squared y times the 4th root of 2y. Our next topic then was learning to add and subtract radicals. Well, that's the same rules that you encounter for needing like terms. So you check and you make sure that your square roots are identical. Cube root of 2, cube root of 2. So then you're just combining your coefficients. It works just like if you were doing 7x minus 1x, that would be 6x. Well, combine your coefficients, 7 minus 1 is 6, and you keep the radical part. So it's just 6 times the cube root of 2. In this next one, if you look at this, they have the same index, but our radicals are different. So go ahead and break down the cube root of 40. See what that breaks into. 20 and 2, 10 and 2, and 5 and 2. I have a group of 3 2's, so that means I would have 2 times the cube root of 5 left over. And over here I have 12 times the cube root of 2. So I look at this and I compare are my radicals identical? They're not. So that's as far as I can go. Now, if it had simplified to a cube root of 2, I would be able to combine it. So what I mean is if it had been 12 times the cube root of 2 minus 2 times the cube root of 2, that you can combine and make 10 times that's a sloppy 3, cube root of 2. After that, we learn to graph cube root and square root functions. So this is a square root. I start by looking at my radical, square root. So that had 2 key points we always used. Those key points were 0, 0, and 1a. Okay, so what was a in this scenario? A is this leading coefficient. So I'm going to use 1, 2 as a starting critical point. And then I'm going to translate it. Remember, if it's inside the radical, it's a horizontal shift left to right. This is a vertical shift up 3. So that means I'm going to add 3 on to each of my y values. So my new ordered pairs would be 0, 3, and 1, 5. So I'm going to graph 0, 3, 1, 5, and it looks like this. It's like half of a parabola on its side. If I ask you for the domain, it starts at 0 and it goes to infinity. The range, how low to how high, begins at 3 and goes to positive infinity. If you were given the cube root function, okay, so if it's a cube root, we started with 3 critical values. The same 2 as square root, so 0, 0, 1a, which would be 1, 2, and then the opposite of 1 and the opposite of a, so negative 1, negative 2. But then we're going to translate. How are we translating this time? Well, there's a minus 3 inside, so that means we're going to go to the opposite of what you would think. So right 3, and we're going up 4. So if I go right 3, that means I will add 3 on to each of my x values. And if I'm going up 4, that means I'm adding 4 on to each of the y values. So let's check out what these new ordered pairs would be. So my x's would go to 2, 3, and 4. My y's would be add 4 to each of those, and I'd get 2, 4, and 6. Okay, so let's graph those. 2, 2, 3, 4, and 4, 6. And hopefully you remember that the cube root function makes like a stretched out s, unless the a is negative and then it's an s that gets flipped. So it's gonna be like this. Kind of missed that ordered pair there in the middle. There we go. And both the domain and the range for this would be all real numbers. And we learned in interval notation that would be negative infinity to positive infinity with parentheses on both. Final topic that we have covered is radical equations and equations with rational exponents. So in general, your goal is to get this cube root part all by itself. So you undo, you're working through the order of operations backwards, so you undo addition and subtraction first. So you need to subtract 2. If you add 2 and 3, that's wrong. You should not, they're not like terms. So 3 times the cube root of x minus 1 equals 6. Now I'm going to get rid of the coefficient of 3 by dividing by 3, which gives me the cube root of x minus 1 is equal to 2. And now I do inverse operations. The opposite of the cube root is cubing. So cube both sides, which leaves me with just the radicand of x minus 1 equals 8. Final step, add 1 to both sides, and I get x equals 9. Now, it's always a good idea to check for extraneous roots. If you take 9 and plug this back in right here, 9 minus 1 is 8. Cube root of 8 is 2. 3 times 2 is 6. Add the 2 and you get 8. So it works. Let's do an equation that contains rational exponents. So your goal this time is to get this x plus 2 to the 3 halves by itself. So you need to begin by dividing both sides by 4, which gives you x plus 2 to the 3 halves equals 27. Now to get rid of that to the 3 halves power, what you do is you raise it to the reciprocal, which would be to the 2/3 power. Got to do it on both sides. Why do we do that? Well, 3 halves times 2/3 is just 1. So you get x plus 2 on the left. And reminder, that's because power to a power, you keep your base, the x plus 2. You multiply your exponents, so 3 times 2 is 6, 2 times 3 is 6, and 6 over 6 is 1. Hence, just x plus 2. You can type the right side in your calculator. What you're actually doing, though, for those of you who are good at mental math, taking the cube root of 27, which is 3, and then you're squaring it, and that gives you 9. Final step, subtract 2, and I get x equals 7. Lastly, always a good idea to check for extraneous solutions. If you plug in 7 plus 2 is 9. Square root of that, or to the 3/2 power, which would be the square root, would be 3. Cube it, that's 27, and times 4 is 108. So we're in good shape. All right. So this is, of course, a sampling of the types of questions you will see on tomorrow's quiz. You can certainly rewatch it if you need more assistance, or go back to previous folders in Schoology for additional examples.